Alright, 8th graders, central angles and arcs. If we remember, if we have a circle, we have 360 degrees within that circle. And if we were to divide it into quarters, I would have 4 angles of 90. So the sum of each angle will obviously measure 360. So that's going to be the basis here as we go through our lesson here today. Example 1, draw a circle with central angles that divide the circle evenly into thirds. Draw a circle. Put one radius in there and use a protractor to guide. So that'll be 120 degrees. So again, this will be 120 over here, and this too will be 120 degrees over here. So 360 divided by 3 is 120, and then I can go ahead and insert those using my protractor to make sure that each angle is 120 degrees. Example 2. The court of a playground game is painted on the blacktop. The court is formed by a circle with 2 intersecting diameters forming 4 central angles. One of the central angles measures 50 degrees. Find the measures of the other angles. So I've got 2 intersecting lines. I know that this is 50. So this is going to be 50. So 50 plus 50, make sure you don't think that's 150 there, is 100. That leaves me 360 minus 100 will be 260. 260 divided by 2, that will be 130. So that means each of these large angles here equals 130 degrees. Alright, we want to talk about an arc. And actually I'm going to pull in another circle over here. When an arc includes half of the circle, so this part over here, we call that a semi-circle. Okay. Because it is exactly half, so I can't say it's more or less than half. However, let's make this a quarter. Let me make that line low. And the other one will make more than half. In this situation here, this is what we call a major arc, and this over here would be a minor arc because it's less than half. Less than half is of the circle is a minor arc. More than half of the circle is a major arc. Or you can have exactly half, which would be a semicircle. Okay. And we can name those types of arcs. I'm going to put up some black dots on here. This is A, B, C. I would say that's the major arc is A, B, C, and then you put kind of a rounded symbol above it. Whereas the minor arc over here, we would just say that's A, C again with a little bit of a rounded symbol there. So understanding those arcs can be important. Let's take that then on to example 3. Here we've got a circle. I've got an angle that looks like that, A, B, D. And this is 60 degrees here, and this is the length of that radius there is 6. So what is the measure of A to D in degrees? And then Well, the measure of the arc equals the measure of its central angle, so A to D would equal 60 degrees. Doesn't matter where you're in there, but we've taken up 60 degrees of the circle. Then it asks, what fraction of the circumference is the arc intercepted by ABD? So the arc, we want to know, well, it's 60 degrees. What they're asking is about this little piece right here. They're saying, what fraction is that of the whole circle? Well, it's 60 degrees, so 60 out of 360, I know I can reduce that to 1/6. So A to D is 1/6 of the circumference of the circle. And the last question asks about what is the length of that arc, of that blue line there, from A to D. And we can understand that by using circumference. So circumference equals pi times diameter. Now we know the radius is 6, so the circumference is going to equal pi times 12. And here they want us to keep pi as pi. And now I just need to use this fraction, which tells me I have 1/6 of the circle. So take this number, and what's 1/6 times pi times 12? 1/6 of 12 is going to be 2. So my answer here is going to be pi 2, and 6 is in centimeters. So that will be my answer. The length of this circle is pi times 2 centimeters. So that's how we can figure each of those out. Alright, 8th graders, you can get started on your practice set here.